Welcome to Service Mesh. Please consider subscribing to the channel. I produce videos daily covering AWS, Azure, and GCP. Also hit the bell to get notified of new videos. Thank you in advance for your subscription. Welcome to our journey into Cloud Service Mesh. Think of this as learning about the smart road system for your applications. I'm going to start with a simple analogy that will make everything click. Imagine your application isn't just one big program, but a collection of many small, independent programs that need to talk to each other. Today we'll explore what happens when this communication becomes chaotic, and how a service mesh solves these real-world problems that every company with microservices eventually faces. The microservices challenge. Let me paint you a picture of what happens as your application grows. You start simple. Maybe just a web frontend talking to a database. But as your business grows, you break things apart for good reasons. Your e-commerce site now has separate services for users, products, inventory, checkout, payments, recommendations, and more. Each team can work independently, deploy separately, and scale their piece as needed. But here's where things get interesting and challenging. These services need to communicate constantly. The checkout service needs to check inventory, validate the user, process payment, and update recommendations. Suddenly you have a web of communication that's growing exponentially. When communication becomes chaos. Now, imagine this growing web of services as a city with no traffic management system. No traffic lights, no road signs, no GPS, just chaos. This is exactly what happens with microservices communication. You lose visibility into who's talking to whom. Security becomes a nightmare because any service can potentially access any other service. When things break, you have no idea where the problem is. I've seen companies where a simple user login request touches 15 different services, and when it's slow, nobody knows which of those 15 services is the bottleneck. It's like trying to debug a traffic jam without being able to see the roads. Introducing the Service Mesh solution. This is where Service Mesh comes to the rescue. Think of it as installing a futuristic, intelligent traffic management system across your entire city of microservices. The brilliant part is how it works. Instead of requiring you to rewrite your applications, it places a tiny smart traffic cop next to every single service. We call this a sidecar proxy because it rides alongside your service like a motorcycle sidecar. Your services don't even know these proxies exist. They just send traffic to their usual destinations, but now all that traffic is being intelligently managed, secured, and observed. The sidecar proxy architecture. Let me show you exactly how this sidecar proxy architecture works. Before, your product service would talk directly to your checkout service. Just a simple network call. With a service mesh, we insert a proxy container right next to each service. Your product service still thinks it's talking directly to checkout, but actually, its traffic goes to its local sidecar proxy first. That proxy then communicates with the checkout service's sidecar proxy over a secure, monitored connection. The checkout service receives the request from its local proxy, processes it, and sends the response back the same way. This might seem like extra complexity, but it gives us superpowers without changing a single line of application code. Google's managed approach. Now, here's where Google Cloud makes this incredibly practical. Traditionally, setting up and managing a service mesh was complex. You'd need to run your own control plane, manage certificates, and handle upgrades. Google's Cloud Service Mesh is built on the popular open-source Istio project, but Google handles all the difficult management for you. They run the control plane, handle upgrades, manage security certificates, and ensure everything scales properly. You get all the benefits of a service mesh without the operational overhead. It's like having a team of service mesh experts managing your infrastructure 24/7. Observability, your traffic control center. The first superpower you get is incredible visibility. Remember our traffic analogy? Now you have a control tower with a real-time view of every road in your city. Every single request between services is measured and recorded. You can see exactly how many requests per second are flowing, how long each request takes, and which ones are failing. But it goes deeper than just metrics. Distributed tracing lets you follow a single user request as it hops through multiple services. Imagine being able to track one car through the entire city and see exactly where it got stuck in traffic. I've used this to debug issues that would have taken days to find manually. Instead of guessing which service is slow, you can pinpoint it in minutes. Security. Zero Trust Networking. The second superpower is security that's both strong and automatic. The mesh implements what's called Zero Trust Networking. Essentially, trust no one, verify everything. Every single connection between services is automatically encrypted with mutual TLS. That means not only is the conversation private, but both sides prove their identity to each other. Your product service can be 100% certain it's talking to the real checkout service, not an imposter. You can then layer on authorization policies. For example, you might say only the web front-end service can talk to the user's service or block all access to the admin service from outside the cluster. The beautiful part is that this security is enforced by the infrastructure, not your application code. Developers can't accidentally bypass it. Traffic management. Intelligent routing. The third superpower is sophisticated traffic control. Think of it as having smart traffic lights that can adapt to conditions in real time. If a service is overloaded and failing, the mesh can automatically implement circuit breaking, temporarily stopping traffic to let it recover. It's like redirecting traffic around a construction zone. Smart retries mean that if a request fails due to a temporary network hiccup, the proxy can automatically retry it a few times before giving up. This makes your entire system more resilient to transient failures. But my favorite feature is canary deployments. You can safely test new versions by sending just 1% of traffic to the new version, monitoring it carefully, and gradually increasing if it's performing well. Canary deployment in action. Let me show you how elegant canary deployments become with a service mesh. Imagine you have a new version of your product service that you want to test. Without a mesh, this is complex. You need to manage load balancers, carefully route traffic, and monitor multiple endpoints. With a mesh, you simply deploy both versions and configure a traffic split. In this diagram, you can see how the routing proxy intelligently splits traffic. 99% goes to your stable version 1.0, while just 1% goes to the new version 1.1. If the canary performs well, you gradually increase its traffic share. The beautiful part is that if something goes wrong, you can instantly route all traffic back to the stable version. I've seen this save companies from major outages during deployments. Google Cloud Architecture. Now let's talk about how this actually works in Google Cloud. The architecture has two main components. Understanding this separation is key to appreciating the value. First, there's the Google Managed Control Plane. This is the brain of the system that lives outside your cluster in Google's infrastructure. You configure policies and rules through the Google Cloud Console or G-Cloud commands, and Google handles all the complexity of running this control plane. Second, there's the data plane, the sidecar proxies that run inside your GKE cluster alongside your applications. The control plane pushes configuration to these proxies and receives telemetry data back from them. This separation means you get all the benefits without any of the operational burden of managing the control plane yourself. When do you need this? Before we dive into setup, let us talk about when a service mesh makes sense. This is important because while service meshes are powerful, they do add complexity. If you have just one or two simple services, a service mesh is probably overkill. You can handle security, observability, and routing with simpler tools. But when you have a dozen or more microservices, and especially when you are struggling with visibility, security, or reliability between services, that is when a service mesh becomes essential. I usually tell teams, if you are spending significant time debugging inter-service communication issues, or if you are worried about security between services, it is time to consider a service mesh. Preparing your environment. Let's get practical and walk through setting up cloud service mesh. The first step is ensuring your Google Cloud project has the right APIs enabled. Cloud Service Mesh builds on several Google Cloud services, so we need to enable their APIs. The core ones are the Container API for GKE, the GKE Hub API for connecting clusters, the Mesh API itself, and GKE Connect for secure communication. I always do this step first because enabling APIs can take a minute or two, and it's easy to forget until you hit an error later in the process. The second requirement is that your GKE cluster must have Workload ID enabled. This is Google's secure way for workloads in your cluster to authenticate to Google Cloud services, creating a mesh-ready cluster. Here's what a mesh-ready GKE cluster looks like. The critical flag is the workload pool parameter, which enables workload identity using your project ID. I always recommend using a release channel for any cluster that will use managed features like Cloud Service Mesh. Google tests all the integrations together and ensures compatibility. For machine type, make sure your nodes are large enough to run both your applications and the sidecar proxies. Each proxy uses some CPU and memory, so I typically go one size larger than I would for a cluster without mesh. If you've been following the previous guides in this series, your cluster should already be compatible with these settings. The magic switch. Here's where Google Cloud really shines in terms of simplicity. Enabling a service mesh used to require downloading complex installation tools, configuring certificates, setting up the control plane, and managing upgrades. With Google Cloud, you literally just flip a switch on your existing cluster. When you run the G Cloud Container Clusters Update command with the Enable Mesh flag, Google provisions a fully managed control plane for your cluster in the background. Think of it like this. You're telling Google, please manage a service mesh control plane for this cluster, and Google handles all the complexity. You don't need to install anything, manage any certificates, or worry about upgrades. After this command completes, the mesh is enabled, but it's not managing any traffic yet. We still need to tell it which applications to manage. Understanding namespace injection. This is where the concept of automatic sidecar injection comes in, and it's a beautifully elegant approach. In Kubernetes, a namespace acts like a virtual folder for organizing your applications. When you label a namespace for service mesh injection, you're telling the system that for every application you deploy into this namespace, it should automatically add a sidecar proxy container next to it. The injection happens automatically and transparently. You deploy your application exactly as you always have, but the mesh injection system intercepts that deployment and modifies it on the fly to include the sidecar. Your applications don't know the sidecar is there, and you don't need to modify any of your deployment configurations. It's like having an invisible assistant that automatically adds the traffic management capabilities. Labeling for injection. The labeling step is simple but crucial. We are adding a special label called Istio injection equals enabled to our namespace. Remember, Google's Cloud Service Mesh is built on Istio, so we use Istio's labeling convention. I usually start with the default namespace for testing, but in production, you would typically create dedicated namespaces for different applications or environments. Once you apply this label, the automatic injection is active. From this moment forward, any new pod created in this namespace will get the sidecar proxy automatically added. Note that this only affects new deployments. If you have existing applications running, you will need to restart them to get the sidecars injected. Deploying sample applications. For our demonstration, I'm using the Bookinfo sample application that comes with Istio. This is a great example because it has multiple microservices that communicate with each other: product page, details, reviews, and rating services. The beautiful thing is that we deploy this application exactly as we would any other Kubernetes application. We use kube control apply with a YAML file, just like always. But because we labeled our namespace for injection, the mesh injection system will automatically detect these new pods being created and add sidecar proxies to each one. This demonstrates the power of the service mesh approach. We get all the benefits without changing our deployment processes or application code. Verifying success. Now comes the moment of truth, verifying that our service mesh is actually working. The key thing to look for is in the ready column when you run kubectl get pods. Normally, you'd see 1/1 for each pod, meaning one container is running. But with the service mesh, you should see 2/2. This means 2 containers are running in each pod. The first container is your application, the product page, details, reviews, or rating service. The second container is the Istio proxy sidecar that was automatically injected by the service mesh. This 2/2 is your proof that the service mesh is working. Every request between these services is now flowing through the sidecar proxies, giving you all the observability, security, and traffic management capabilities we discussed. Exploring the benefits. With your application now running in the service mesh, you can start exploring all the benefits we discussed. Head over to the Google Cloud Console and navigate to the Anthos Service Mesh page. You'll see a topology graph showing how your services are connected. It's like a real-time map of your application architecture. You can click on any service to see its golden signal metrics: latency, traffic volume, error rate, and saturation. This is where the service mesh really pays dividends. Instead of wondering why your application is slow, you can immediately see which service is the bottleneck. Instead of guessing about security, you can see exactly which services are communicating and apply policies to control that communication. The next steps would be setting up more sophisticated routing rules, implementing canary deployments, and creating security policies, but you now have the foundation in place to do all of that.